In this video, we are going to discuss the basic concepts and notations of sequence. So first of all, what is a sequence? So sequence is a list of numbers. So a list of numbers. So can you give me a list of number? Very easy. 1, 2, 3, 4, 5, 6, 7, so on and so forth. So this is a sequence. So what about series? So people usually talk about sequence and series at the same time, right? What about series? So series is the sum of a list of numbers. The sum of a list of numbers. So instead of writing a bunch of number and then separate them by comma, so we will do this 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7, and then we keep on going. So this is a series. Sequence is a list of a number. Series is the sum of that list. All right? Okay, so more about sequence. So in sequence, do you see that we have 1, 2, 3, 4, 5, 6, 7, and 8, so on and so forth. So the 1, 2, 3, 4, 5. So let's do this. So the 1, we can call this the first term of a sequence. So we call it the A1. So the A stands for a term in the sequence. So you can think about this as a member of a sequence or one of the elements in a sequence. And then A2, so that will be A2, then that will be A2, and then A3, A4, A5, so on and so forth. So what is the pattern? The pattern is, well, from 1 to 2, from 2 to 3, the increment is 1, right? So the increment of this sequence is equals to 1. So that means A2 is equals to A1 plus 1, and then A3 is equals to A2 plus 1, right? So every time you want to get a term, to get the specific number, you have to take the previous number, you add 1 to it, so you get to the next number, right? So the A1, A2, A3, A4, and A5, so these, we call these terms. So there are 5 terms in this sequence. There are 6 terms. So A1 is 1 term, A2 is the next term, A3 is the next term, and then in this sequence, how do I get the 100th term? So to get the 100th term, you have to use the 99th term plus 1, which is equals to 99 plus 1, that is equals to 100, right? So now, more vocabularies. So we introduce the term, we introduce the sequence and series, and then the next thing that I would like to introduce is a finite sequence. So we have A1, A2, A3, A4, and then we go all the way to AN. So we just go from the first term to the nth term. So there are countable number of terms, right? So if n equals to 100, then we know there are 100 terms. If n equals to 10, then we know there are 10 terms. If the subscript n is equals to 15, we know that there are 15 terms. So this is called a finite sequence. So finite means countable sequence with n terms. What if we keep on going? So what if we have A1, A2, A3, A4, and then we go all the way to AN, and then we don't stop, and then we keep on going? Then this is a infinite sequence with infinitely many terms. So infinite sequence. With infinitely many terms. How do you write a sequence? So first of all, let's discuss how to write a finite sequence. So let's say we have this. So let's change that to another color. So let's say we have let's say n divided by 2, and then n goes from 0 to 5. So this is a finite sequence because when n is equals to 0, we have 0 over 2, n equals to 1, n equals to 2, n equals to 3, n equals to 4, and then n equals to 5. So this is a finite sequence. And I have to remind you, n doesn't have to start at 0. n can start at any integers, 0, -1, 1, 2, 3. It doesn't have to start at 0. So this is a finite sequence with how many terms? So it's countable, right? So in this list, you can see that there are 6 terms. So this is a finite sequence and with 6 terms. All right, so how do you write an infinite sequence? Before we move on to infinite sequence, what is the n divided by 2 stands for? This n divided by 2. This n divided by 2 is called an. So we call this the nth term. An is equals to n divided by 2. So this is the nth term of this sequence. So if you want to know the specific term, so let's say n is equals to 4, then you plug in 4 to n, then the fourth term, the a fourth is what? Is 4 divided by 2. So if you want to look for a specific term, that is how you get the 0th term, the first, second, third, and fourth. So all you have to do is you plug in an n, and then what is the an stands for? This an, very important. We will have to use this a lot in this lesson. This an describes the pattern of the sequence. All right, an describes the overall pattern of this sequence. So this is a finite. What about infinite? So infinite, let's switch color for infinite. So for infinite, here is what we can do. So I'm going to give you another one. How about n divided by n plus 1, such that n goes from 1 to infinity? So what is my an? So in general, the pattern of this sequence is every time you want to look for the n value, you have to take that n divided by n plus 1, right? So this is called an infinite sequence. Why? Because it doesn't terminate. It just keep on going forever, right? N equals to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then we go all the way to infinities, right? So that is called an infinite sequence because there are infinitely many terms. So when n is equals to 1, we have 1 divided by 2, right? When n is equals to 2, we have 2 divided by 3. When n is equals to 3, we have 3 divided by 4, n equals to 4, n equals to 5, and then we keep on going, right? So this, the 1/2, we call that a1, and then the 2/3, we call that a equals to 2, not 3, a2, a3, and then we keep on going. So what is the pattern of this sequence? So the overall pattern is right here. So this is the overall pattern. So the overall pattern tells me if you want to look for a specific value, you have to take that value divided by that value itself plus 1, so that this describes the overall behavior or the overall pattern of this sequence. So let's move on to one of the very famous and fundamental sequence that is called the Fibonacci sequence. So let's write this down. The Fibonacci, so the Fibonacci sequence. So this is called Fibonacci sequence is because it is invented by a mathematician called Leonardo Fibonacci. All right, so what is Fibonacci sequence? So here is Fibonacci. So 1, 1, 2, 3, 5, 8, 13, 21, and then we keep on going. So now what I want you to do is, can you tell me what the first term is? So this is A1, right? And then A2, and then A3, and then A4, and then A5, A6, A7, A8, and then we keep on going, right? So what is AN in this case? So the AN is, can you tell me the overall pattern of this sequence? So you observe this list. What pattern do you see? So the pattern is the nth term is equals to the sum of the previous 2 terms. So that is equals, AN is equals to the previous term, the sum of the previous 2 terms, which is n minus 1 and n plus 2. So let's say when n is equals to 3, so we have 3 minus 1 is 2, and then 3 minus 2 is 1. So that means A3 is equals to 1 plus 1, that is equals to 2, right? So take a quick look. So 2 is equals to 1 plus 1. 3 is equals to 1 plus 2. 5 is equals to 2 plus 3. 8 is equals to 3 plus 5, and then 13 is equals to 5 plus 8. So that is the overall pattern of this sequence. And again, the overall pattern can be described as an is equals to an minus 1 plus an plus 2. The current term is equals to the sum of the previous two terms. So that is the end of this video. So we just introduced what a sequence is, what a series is, and then we introduce all the basic vocabularies. In the next video, I will give you two examples to explain the term and a general term of a sequence. All right, so if you think my instruction is helpful, please like, subscribe, and share the video for me. What do you think about this? Let me know in the comment section below. I appreciate your help really, really much. Thank you for watching. I see you all in the next one. Signing out for now.